All right, this week, the week of 10/18, we learned about RER and how RER ranged on a scale from 1.0 to 0.7, and the closer to 1.0 you are on the RER scale, the more carbohydrates you're burning, and the closer to 0.7 you are on the scale, the more fat you're burning, and how if you are using Krebs and ETC, you will be closer to 0.7, and if you're using glycolysis, which is what you're most likely going to be using through resistance training, like I was today hitting chest, you will be closer to 1.0 burning carbohydrates for a fuel source. We also learned about this week the oxyhemoglobin dissociation curve, and to be honest, it is really confusing, and I'm not sure how well I'm going to do at explaining it, but basically it is the relationship between partial pressure of oxygen and oxygen saturation, which are x-axis being partial pressure and y-axis being oxygen saturation, and how there are four really big factors that affect your where you are on the oxyhemoglobin dissociation curve, being temperature, pH, carbon dioxide, and hydrogen. And yeah, I am a little confused on it right now, but if your curve moves more to the right, that means you have an increased temperature, a decrease in pH, which means higher acidity, which means higher hydrogen accumulation, and then an increase in carbon dioxide. Basically, what I learned through the oxyhemoglobin dissociation curve as I was working out today was that the more hydrogen accumulation I have in my muscle, the lower my pH, the higher the temperature, higher the carbon dioxide, the further right I am on the oxyhemoglobin dissociation curve. So when I'm hitting like a heavy set of squats or even a light set of squats, I'm just going to absolute failure, and I have a bunch of hydrogen in my muscle, the further right I am on the curve because of the accumulation of hydrogen. Yeah, that was it's cool to learn these things and apply them and thinking about them as I'm working out, like I did today with my friend.